Okay, so let's look at the Unit 2 Practice Day lesson. This is kind of recapping everything we have done this unit. We're going to touch on pretty much everything, one or two problems of each, and we'll go from there. And for the most part, we'll go in order even. So first, they ask us to find the coordinates of the midpoint of a segment with the given endpoints. Well, if we remember our formula for midpoint, that's where we do the whole x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. That's the formula we're going to use. So now let's look at number 1. First thing we need to do is label our points. X1, Y1, X2, Y2, and then at that, now we just plug into the equation. So X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. Seven plus 4 is 11. 1 plus negative 1 is 0. So I can't reduce 11 over 2. I'll just leave it like that. But 0 divided by 2 gives me 0. So there's my answer. Then we're going to do the same thing for number 2. Label our points. X1, Y1, X2, Y2, and set up our equation. 5 plus 3 divided by 2, and then negative 3 plus negative 8 divided by 2. 5 plus 3 is 8. Negative 3 plus negative 8, negative 11. Can we reduce anything? Yes. 8 divided by 2 is 4. And then we have negative 11 over 2 that cannot be reduced. So that's finding the midpoint. Now they're going to give that to us, and we're going to have to do that deal where we got to draw a graph and find the other end point. So it says find the coordinates of G if F is the midpoint. So F is in the middle. And J has coordinates of 6, negative 2. Okay, so when I draw my axes here, they're going to look a little off because I'm trying to put as much of this on the graph as I can. I know some people are OCD, they want it to go exactly down the middle. I'm going to not do that because I want as much of this on my graph as possible. So there's my x-axis, there's my y-axis. Okay, one of our endpoints J is at 6, -2. So let me count over to 6, -2. 1, 2, 3, 4, 5, 6. Down 2. That's where J is sitting. F is in the middle at 1 and 3.5. So there's where F is sitting. Now, I have to figure out how did I move to get from J to the middle, which is F. Well, y'all know by now I can't draw straight lines, so let me try my best to get a straight line going here. Okay, good enough. So what did I do? I went over 1, 2, 3, 4, 5, and then I went up 1, 2, 3, 4, 5 and a half. So now I gotta do the same thing. Let's go over 5. 1, 2, 3, 4, 5. I'm gonna go up a half first, just so I get my half out of the way. So there's my half. Now, how many holes did I go up? Looks like 1, 2, 3, 4, 5 holes. So 1, 2, 3, 4. Oh, I need to go 1 off the graph. 5. So here's my new point, G. There's my point G. So what are our coordinates of G? Well, we went 1, 2, 3, -4 over. But then how high did I go? 1, 2, 3, 4, 5, 6, 7, 8, 9 up. So there's our coordinate, -4, 9. Okay, now let's repeat the process for the next one. Again, my axes are going to kind of look wonky, but that's because I'm trying to fit as much of this on my graph as possible. The other way we would have to do it is algebraically if we couldn't do it on the graph. So I'm trying to fit it all on the graph. So there's my y-axis. This is going to have to be my x-axis. Okay, let's see what it says. They ask us to find the coordinates of A if B is the midpoint. B is in the middle. C has coordinates of 1, 7. So I'm going to go 1 up to 7. So C is going to be up here. Then I'm going to a middle of -3, 1. So right there. That's B. Let's get our ruler and try to draw a straight line between the two. Okay, there we go. So how did I move? Remember, B is my middle here. This is the midpoint. So I went down 1, 2, 3, 4, 5, 6. And I went over 1, 2, 3, 4. Now, since I'm about to run out of the graph and I see that, I'm going to go over 4 first so I know where to stop when I go over. 1, 2, 3, 4. Okay, so I'll be on this line for sure. Then I need to go down 6. 1, 2, 3, 4, 5, 6. And then try to draw my straight line between them. So that's our coordinates for A. Kind of down here in problem 5, but that's okay. So A is what? How much did I have to go? What's my X coordinate? 1, 2, 3, 4, 5, 6, 7. It looks like I went to -7, and then how much did I go down from the x-axis? 1, 2, 3, 4, 5. Went 5 down, so -7, -5. There's our answer. Okay, so that was the first day of Unit 2. Now let's look at the second day of Unit 2. On that day, we talked about distance and the Pythagorean Theorem. So remember our distance formula. That's the one, that's that big square root. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we'll start the same way. We'll label our points, x1, y1, x2, y2, and then find our distance, jk. Just kidding, guys. Okay, so let's set up our big square root. I'm not really kidding. We're finding it. Sorry. So x2 minus x1. 2 minus negative 3 squared plus y2 minus y1, which would be negative 4 minus 4 squared. Now, if you type in the calculator just what's under the square root, what would you get? And if you're doing this along with us, maybe you want to hit pause for a second so you have a chance to try it in the calculator. You should get the square root of 89. Which, if we round to the nearest tenth, they don't tell us to, but that's what we've been doing. The nearest tenth would be 9.4. There's our distance. Okay, number 6. Label our points. x1, y1, x2, y2. Then we do RT. So that's going to be x2 is 5 minus 2 squared plus y2 is 7 minus y1, which is 3 squared. If you do just what's under the square root, what would you get? You should get 25. And this time it's a nice number. The square root of 25 is just 5. Okay, keep it moving and look at 7 and 8. So these ask us to do the Pythagorean Theorem. Remember, the Pythagorean Theorem is the whole a squared plus b squared equals c squared. So I need to connect my points here. So on 7, I'm finding the distance of ML. Well, how much did I go up? 1, 2, 3. So that's going to be 3. How much did I go over? 1, 2, 3, 4, 5, 6. So that 3 and that 6 are what I'll plug into A and B for. I'll have 3 squared plus 6 squared equals C squared. 3 squared is 9. 6 squared is 36. 9 plus 36 is 45. And then I have to take the square root and let's see, the square root of 45 is approximately 6.7. So LM is 6.7. That's number 7. Now number 8's a little tricky because if we look at our scale, they're actually counting by 2's. They're trying to trick us here. And as much as they're trying to trick us, and as big of a deal as I'm making of this, I guarantee y'all that half of y'all will fall for this trick on the guided practice. I mean, the assignment. There is no guided practice today. Come on, ruler. Come on, ruler. Close. Close enough. There. So there's our line. Now let's see how much they move. We go down 2, 4, 6, 8, 10. We go down 10 and over 2, 4, 6, 8, 10. You know, now they're counting by 2's again because I can look at this scale and see it goes, each line is 2. 2, 4, 6, 8. 2, 4, 6, 8. Who do we appreciate? So 10, 10. That's our A and our B. 10 squared plus 10 squared equals C squared. 10 squared is 100. 100 plus 100 gives you 200. And then we need to square root it. So the square root of 200 is approximately 14.1, which means that EF is equal to 14.1. So that was the second day, distance and Pythagorean theorem. Now let's go on to the third day where we look at slope. And we're going to do this by mainly determining if lines are parallel, perpendicular, or neither. So in each case, we're dealing with line WX and then YZ. So I'm going to run through my points here and highlight all the WX's. That way I know they go together. And then the YZ's go together. Okay, so let's start on number 9 and do WX first. Oh, well, I guess it might help if we have a formula. So remember for slope, that's where we do y2 minus y1 divided by x2 minus x1. Okay, label our points. x1, y1, x2, y2. And then if we do the slope of wx, we get 5 minus 4 over 4 minus 2, which is 1 over 2. Then we do the slope for YZ. Label my points, x1, y1, x2, y2, y2 minus y1 over x2 minus x1. Negative 7 minus 1 is negative 8. 8 minus 4 is 2. Can I reduce that? Yes. Wait, no. 8 minus 4 is not 2. 8 minus 4 is 4. Negative 8 divided by 4 is negative 2. Okay, so what do we know this then about our slopes? 1 is 1/2. The other is negative 2. And in case you can't remember parallel, parallel means they have the same slope. Perpendicular means they're opposite reciprocals. So they're flipped and one's negative. Well, if I take this negative 2 and put it over 1, look, they're flipped and one's negative. So this one would be perpendicular. Okay, number 10. Label my points. x1, y1, x2, y2. We're going to start with wx. So negative 5 minus 3 over negative 2 minus 1. Negative 5 minus 3 is negative 8. And then negative 2 minus 1 is negative 3, which turns into 8 over 3. Do the same thing for YZ. Label my points. X1, Y1, X2, Y2. So Y2 is 3 minus Y1 is -2 over 8 minus -6. 3 minus -2 is +5 over 8 minus -6 is 14. What do we notice about these two slopes? They're totally different. Totally different. So these would be neither. And number 11 now. So found the slope of WX. I'll label my points. Y2 minus Y1 over X2 minus X1. Oh, forgot my -7. 9 minus 6 is 3. -6 minus -7, +1. So that's just 3. Then we have our YZ here. Label the points. Y2 minus Y1 over X2 minus X1. -6 minus 3, -9. 3 minus 6, -3. -9 divided by -3 is 3. So if we look at these two slopes, they are the same, which means these two lines are parallel. Oh, that was just the front. So now let's flip over to the back. Twelve's asking us to do more slope. Oh, we've been doing slope the past 3 problems. So let's just keep doing slope. So label our points, X1, Y1, X2, Y2, and find the slope. Y2 is 7 minus Y1 is 3 over -4 minus -4. Let's see, that 7 minus 3 is 4 over -4 minus -4, 0. Ooh. Can we divide by 0? No. So that means this slope is undefined. If you can't remember the word undefined, just think of slope man. So the U here is our vertical line. If we notice, we've got the same x values here. So that tells us we have a vertical line. Wait, I totally did that wrong. Slope man, you're supposed to be winking at me. There we go. Okay, 13 asks us to write the equation of a line in slope intercept form. Oh, what form is that? Slope intercept is y equals mx plus b. They tell us the slope is -7, so m equals -7. There's a y-intercept of 0, 4. Remember, our y-intercepts are always in the form of 0, b. So that means our b here is 4. We've got our m, we've got our b. Let's just write our equation. Y equals -7x plus 4. That's it. We're done with that one. Fourteen asks us to write the equation of a line in point slope form. Well, come back, come back, come back, come back, come back. Point slope form. What form is that one? That's where we say y minus y1 equals m, our slope, times x minus x1. They want a slope of -4/5, so m is -4/5. And they give us a point of -3, which is our x1, -6, which is our y1. So let's write our equation. We have all the pieces. We have m, we have x1, and we have y1. So y minus y1 is -6 equals our slope, -4/5 times x minus x1 is -3. Now, what is minus a negative? It turns into a positive. So let's replace these minus and negatives with positives. Then we have our answer. Okay, next they want us to write the equation of a line through these 2 points in slope intercept form. So what form are we looking for our answer to be in? Y equals mx plus b. Now, do they give us the slope here? No, they don't give it to us, which means we have to find it. So label your points. x1, y1, x2, y2, and find the slope. So m equals y2 minus y1 divided by x2 minus x1. 9 minus negative 6 is 15. 8 minus negative 12 is 20. What's 15 over 20 reduced to? 3/4. There's our slope. Now, we've got slope. Do we have our intercept though? Nope, still no intercept. So I'm going to pick this first point since I already have it labeled x1, y1. I'm actually going to do the other version, point slope form, and then convert it to what I need it to be. So I'm going to say y minus negative 6. So that's same as saying y plus 6 equals 3/4 of x minus negative 12. That's the same as saying x plus 12. Now let's distribute my 3/4. So y plus 6 equals 3/4 x plus 3/4 times 12 is 9. Subtract 6. We'll get y equals 3/4 x plus 3. There's our final answer. Okay, 16's a little tricky. They want the equation of a line in slope intercept form. That sounds fair enough. So we need it to be in y equals mx plus b form. We need it to pass through -7, -4. So there's our x1, y1. But we need it perpendicular to this line. Remember, perpendicular means opposite reciprocals. So let's see if I can use this line slope to help me get one perpendicular to it. Well, it's 1/2. If I want opposite reciprocals, I'm going to have to flip this, make it 2/1, and then do the opposite, make it negative. What's -2 divided by 1? Just -2. Okay, so there's my slope I need to use. Here's my slope. We have our point. Again, let's put it in the other format and then convert. So y minus y1 is -4, so actually it would be y plus 4 equals -2 times x plus 7. Minus -7 turns into plus 7. So distribute my -2. I'm going to have y plus 4 equals -2x minus 14. Subtract 4. And get y equals -2x minus 18. That's my final answer. Okay, on to 17. First thing I want to do is draw my axes. These will be normal. Yeah, they'll just be normal. So there's my y-axis. There's my x-axis. Now, they want me to graph the line x equals 2. Okay, I'll go to x and put a point at 2. What kind of line is this? If it is x equals, think back to what we did on that last lesson. X equals gives us a vertical line. So we put our point at 2, and then we need to draw a vertical line. There. That's it. That one's done. Now let's look at 18. Again, let's draw our axes in there. Okay, so they ask us to draw the graph of the line for y equals -3. So I'm going to go to my y-axis and put a dot at -3. Again, this is another special case. Y equals -3 tells us it's a horizontal line, because the y must always stay -3. So I'm going to draw me a horizontal line. And then that's it. And the last group, they want us to say if the lines are parallel. So remember, parallel means same slope, different intercept. Perpendicular means the slopes are opposite reciprocals. Coincide means same everything. And then intersect is just kind of the rest. Now, perpendicular also intersects, so keep that in mind. Okay, 19, 2x plus 4 and 2x minus 10. So if we look at the slopes here, what do we notice? They're the same slope. What about the intercepts, though? Different intercepts. So which one has same slope but different intercepts? Parallel. Okay, for 20, first thing we need to do, look at the slope. So one has a slope of -1/2. One's got a slope of 2. These are opposite reciprocals. So which one has a slope of that's opposite reciprocals? Perpendicular. So these are perpendicular. But if they're perpendicular, what do they also do? They intersect. Because remember, perpendicular is just a special case where they intersect at a perfect right angle. So they still intersect, but they're a special intersection. They're perpendicular. And the last one. So look at your slope. This first one's written in point slope form. So our slope is the 6. Second one's in point slope form. So our slope is -1/3. They're different slopes. Now, are they opposite reciprocals? They're different, but are they opposite reciprocals? No. So these just intersect. Okay, so that's the guided, that's the practice day lesson. There will be no guided practice because the assignment looks exactly, almost exactly like this. We changed the numbers on you, but still. So, hop to it.